Hey everybody, in this video I will be talking about measurements. In chemistry, we usually use the metric system like grams, meters, and etc. While some countries like the US use the imperial system, which include the units pounds, feet, and etc. So the metric system uses SI units, or the International System of Units. Why is it called SI units instead of IS units? Well, in French, the name of this system is actually this, and I'm not going to try to say it because I don't speak French, and I'm sorry that I did not include any of the accents that were needed for these words. So, let's see. So, SI matches SI, and that's why it's called the SI units. Now, let's look at the different SI units on this colorful rainbow circle. We're going to go around in a cycle. So, to start off, we are going to talk about moles. A mole just tells us the number of particles there are. So this will be learned in a future video, but if I say 1 mole of, oxygen, that means that I'm talking about 6.022 times 10 to the 23rd atoms of oxygen. So if I say 1 mole of something, I just mean this amount of something, or this many particles of something. So in this case, 1 mole of oxygen atoms equates to 6.022 times 10 to the 23rd atoms of oxygen. So it just tells us how many there are. Let's look at the next one. Our next one is Kelvin, which measures temperature. So there is a formula that relates Kelvin, K, to Celsius, or degrees Celsius. The formula is as follows. So I'm going to put this in a different color. Kelvin is equal to degrees Celsius plus 273.15. So that's just a nice conversion you could do between Celsius and Kelvin, and that will be very useful in the future. Next, we have something called the ampere. The ampere measures the rate of electric current flow. This will be used in electrochemistry, so we won't go into it right now. Now, this one should be very familiar. It's seconds, which is a measure of time. And then let's go on to the next one, which is meters, which measures distance. A meter is about 3 feet, but not exactly. Now we have a kilogram, which is a measure of mass. The candela measures brightness, but we don't really use this in chemistry, so we can just ignore it for now. And now let's look at our symbols. So let's start with mole. So MOL stands for mole. K stands for Kelvin. A stands for ampere. S stands for seconds. M stands for meters. kg stands for kilograms or kilograms, whatever you like to call it. And CD stands for candela. But remember, in chemistry, we usually don't use candela. So let's just not think about that for now. Let's think of the other 6 that are more important. But if you do take other courses, then the candela will be important, maybe in physics, for example. So now let's move on to the prefixes. Now, I underlined the ones that are the most important that you should know in chemistry. That isn't to say that the other prefixes are not important, but they are used in other courses, and in chemistry, we usually avoid those ones. unless, we really have to use them. But let's just start with the first important prefix. Let's start off with the prefix kilo or kilo. Kilo means 1,000 or 10 to the third as written over here. So if we add the letter K, which is our prefix, in front of the unit gram, we just imply that there are 10 to the third grams. So a kilogram is 10 to the third grams, or 1,000 grams, if you change scientific notation into its numerical form. So let's talk over what happens when you have no prefixes. If you have no prefixes, that just means 10 to the 0 or 1. So, for example, if I say a gram, well, that's just 1 gram. It's like, I don't know, if you have no prefixes, it implies 1. So let's go into the smaller prefixes. Now, what I mean by smaller is that the exponents on the 10 are going to be negative, which means that you are going to have fractions. So let's talk about the deci prefix right over here. Deci is just a tenth, or 10 to the negative 1. So for example, if we say a decimole, so notice how I use the prefix here, and I use the abbreviation for the unit here. I just mean 10 to the negative 1 moles, or 1/10 of a mole. They're the exact same thing. Our next prefix is the centi or centa prefix. Centa means 10 to the negative 2. So if I say a centimeter, I mean 10 to the negative 2 meters, or 1 over 100 meters. And then our next prefixes are milli, which is 10 to the negative third, micro, 10 to the negative 6, nano, 10 to the negative 9, and last but not least, pico, which means 10 to the negative 12. So these are the important prefixes, and let's move on to derived units. Now, what are derived units? Well, they're just any other measurement or unit that comes from the SI units. So the 7 that we saw at the beginning are the 7, fundamental units, and the derived units come from those units. So you've heard of a liter before, right? Well, a liter is equal to 1 cubic decimeter, which will cover a volume equivalent to 1 liter. So in this diagram, the volume is shown as a cube that has sides 1 decimeter, and 1 decimeter. So if you create a cube that, looks like this, with the dimensions that I gave, then that cube will have volume exactly equal to 1 liter. So that's a derived unit for you. Now let's look at another derived unit. Our second derived unit that we will look at is density. Density is written as this symbol right here. It looks like a little P, but it's kind of curved to the left, I guess. And density is just how much mass there is in a volume. So, let me fix that. Let me write that as a cubed, because it's of mass over of volume. So we can write density as grams over centimeter cubed, or grams per centimeter cubed. And we could also write density as kilograms per meter cubed, because as long as you have the mass on top and volume on bottom, it's technically density, because density is a measure of how much mass there is per unit of volume. So many ways to write density. Now let's look at our next example. Our next example is a newton. A newton is basically the SI unit that measures how heavy something is, or maybe the force exerted by something. So Newton measures force. You will probably learn that in physics if you ever take it. So 1 Newton is equal to 1 kilogram times meter per second squared. Now I won't explain why this is so. I'm just kind of telling you that force is defined by using the original SI units that we had at the beginning of this video. We have the kilogram, we have the meter, and we have the second squared all together. So now let's look at one last example, a Pascal. A Pascal measures pressure. So, you know, how much pressure something is exerting. So that's not the same thing as weight, because as you'll see, a Pascal is defined as 1 Newton per meter squared. So notice I took a derived unit and I put it in a system and then used this to derive another unit. So that's very common in chemistry to use one unit from something and apply it into another unit. So what do we mean by pressure? Well, pressure is just the amount of force there is per, I guess, square meter. So that's why it's 1 Newton per square meter, because we are trying to find the pressure, which is the force applied on a certain area. So we won't get into that any further, but that's just an example of derived units. So I saved this last slide to write something very important that you should know. This is a very important concept in chemistry, and it should be memorized. This is what you should memorize. 1 milliliter is equal to 1 cubic centimeter. This thing right here, this conversion between the two units, will be commonly used in chemistry, and it's not that hard to memorize either. So that's all for now. Have a nice day, everyone.